Hello. Please welcome Benjamin from Novoda, who will talk to you about RxJava. Uh, and you will do the conference in English. Yeah. Okay. Enjoy it.
Hi. So yeah, I'm going to talk about RxJava. So who am I? I'm Benjamin, Ben, if you want. I'm from Novoda, Android agency in London. So we focus on Android, do only that, and we hope to get some good experience by focusing on it. You can find me on the usual Twitter, GitHub, Google+, and others. So, Rxify everything. So first, why should you care about it? Why should you even listen to me today? Main reason is concurrency is a massive pain. Data flow is a massive pain. When you code an app, you want to have to care about one thing at a time. You don't want to have to care about handling your data, handling your asynchronous flow at the same time, doing all that. You want to have some structure to separate the two. You want to also use some tools to help you code small functions, like structure your code properly. And that could help. But the main reason is coding is hell. Who in that room has ever had to deal with an API with, let's say, just questionable design? Yeah, that's pretty much what I thought. We have new constraints coming in every day, new requirements, multiple APIs to deal with. Basically, on a day-to-day basis, we have to completely change code, do new things, and we have to deal with that all the time. So this is why RxJava can help you. So what is it? RxJava is actually an implementation of the concept of reactive functional programming. So that comes from the one you see on the right is the reactive extensions from .NET that existed quite a bit of a time ago. And then since then, we have ports of that concept in loads of languages, including in Java. RxJava has been built mostly contributed by Netflix, and it's a fully open source project, so it's quite awesome. And it's an implementation of the pattern Observable Observer. What does that mean? So if you look at data in general, so you have one element, like one value of your type. You have multiple value of your type. So in a synchronous way, it's getting that value or getting an array, an iterable, a list of that type. When you're dealing with something that is asynchronous, you have the concept of future. Who has heard about futures? Yeah, okay, good. So the concept of future is just, when I'm calling getData, I will return automatically, return straight away. I'll just have a future of that value, meaning that value doesn't exist yet. At one point, it will exist. And then you can attach, I don't know, a listener to get updated when that value is ready or something. Observable is the same concept but for multiple values. It's basically a push-to-base collection. So you just say, I can handle a type of a certain type, and I'll get those updates. So it's something that will emit several values. You say, I have a type, I don't know, type dog, whatever, and I get multiple values of that type over time. It will terminate at one point, or not, if it's infinite. But if it ever fails, it will only fail once. And that is kind of a nice API, because if we expect that, then we can actually deal with it and add loads of functionalities. On the other end, you have the observer. The observer is a typed listener. It's something that knows how to deal with values of a certain type, and that will be called by the observable to deliver the content. This will usually sit in your UI levels. This is something you will have in your activity that will receive your data and just deal with, I don't know, updating your views, all that stuff. So you have a lot of nice resources available, including RxJava Wiki, which is on the GitHub Wiki of RxJava. There is a massive number of tools, transformations, actions that you can apply. I'm only going to present 3 of them today before I start the rest, just the one I'm going to use, basically. They're all presented using like a standardized schematics, and this is how you would represent an observable on those schematics. So it's a timeline that goes from left to right, finishes when you have the vertical line at the end, and all those colorful forms and shapes are the events, the values that are being emitted over time. And you can apply a transformation to it, in here flip, and when I apply a transformation, I get back a new observable that emits the values in here flipped. And in that case, at one point, it hits a circle, says, I don't know how to flip it, I will fail, and a failure is marked with a cross. So I'm going to use those schematics, which you will find in the wiki if you use it. The first element I want to show is map. So people who have done a bit of functional programming should be familiar with it. It's something that will apply a transformation on every element. So I can define, I don't know, multiplying by 2. And if I apply map, every element is multiplied by 2. So this is transforming values. The second one that is really useful is flat map. Flat map is composition. I can say that for every element, I want to execute a new observable, a new task, and this is what you could use to chain actions together, multiple API calls, different behaviors. This is where you can like literally branch out, do new behaviors on your app. And the last one I'm going to use today is on error resume next. This is recovery on failure. You can specify if I encounter a failure, I can literally resume with a new task or with a customized failure. I can basically do actions on failure right in my data layers. And the last aspect in RxJava, as I mentioned, asynchronicity is completely put on the side. So you can create your observables, chain them, do loads of things with them, and at the end, when you want to decide where do I execute that, you only have 2 functions to care about it. The first one is subscribe on a scheduler. This will define where do you execute your work. So this is basically saying if I have an API, where do I do the work of my API? Do I do that on a thread pool executor? I don't know, a new thread, somewhere. And the other one is observe on, and this is to define where do you get your results. Your observer at the end will be called on whatever scheduler you specify here. On Android, you could say subscribe on a thread pool executor, observe on Android main thread. And that will automatically execute all your code that is part of the observable deported on the thread pool executor, and you get your UI back straight on the main thread. So all that is nice. It's loads of kind of theory, and it's not that easy to understand. So I'm just going to tell you a story. Let's think about your boss comes, oh, you have to work on a shopping app. So you have no control over the API. It's something that exists for like, I don't know, 2 years. Team doesn't exist anymore. Just have like a small people looking over it. And you have to build a shopping app that integrates with that API. Let's make it simple. You have to build something that can build a basket, add elements to it, and at the end make you pay for it. All is starting well. Yay, it's funny. My first API call is add to basket. And I take a barcode and I return a basket. Awesome. All is good. I could do that using lasting task. Just call my API in the do in background, deliver the results in unpost execute. It's simple. 4 months later, I got loads of changes on my API. It didn't work as I expected, actually. And I have new requirements. And I usually have this. Hell. Like, you don't want to maintain that. You need to add something. You have multiple classes to change, chunk of code to throw away. It's really not a good thing. So how can we Rxify it? How can we make it better? So how would you start using RxJava? This is what you would put in your UI. This is the observer. It expects a type basket, and it has on next basket, I update my UI. On error, I display a dialog for it. Easy enough. How do I implement my data layer? Well, my API, instead of saying add to basket, I return a basket, I return an observable of a basket. This is actually handled for you if you use libraries like Retrofit. The latest version now, you define in your interface of Retrofit return observable, and it works for you. So nice of them. If not, you can just, just wrap it in an observable yourself. So this is how you would define your data layer. This is how you would use it. And you just call add to basket with the barcode that you just scanned. And you call subscribe new basket observer. And that will execute the task, deliver the results straight into your activity. Yeah, so client comes back. Sorry, our API doesn't actually use HTTP standards. Everything is a 200. Everything is OK. If I have an error, it's like a custom JSON or XML. You should have to care about that yourself. OK, well, how do you do that? So let's refactor a bit. So we can define a new type. Let's just say that add to basket returns a response of a basket. And the important thing is that line here. I add flat map, check API success. As you can see, because my type doesn't change in the API here, my UI layer doesn't change. Like I have nothing to change on the activity layers. That doesn't change. So flat map, as I mentioned, is composition. I can actually do more than just a one-to-one mapping. I can either fail or do more stuff. And here, I will fail. So this is how you define a function. So you see this really verbose thing saying func1. That's because Java doesn't have functions as functional languages. So you just say this is a function that takes a response of a basket and return an observable of a basket. It's really verbose, but it's not that difficult. Usually, just look at that bit here in the middle. So I have a response of a basket. If it is a success, I unwrap it. I do response.getBody. If it is not, I fail. I manually here say I return a new custom error. And that will now, on my UI layer, have the effect of having either a basket or an error message. And I didn't have to change anything in my UI layer. OK, 2 days later. Sorry, our API doesn't return a basket. We return a diff. So you have to handle like a local cache. And yeah, deal with it. OK, here we go again. We add one line in here, map, because we're going to transform a diff to a basket, so one-to-one mapping. And I implement my function, apply diff to. So map is the transformation. So my function is literally this, so from a diff to a basket. And how is that implemented? It's like one line, apart from the verbose stuff. I take a diff, I apply that diff to my basket, so I can implement that however I want in my model, but I just need to return the updated basket. OK, so now we have check for custom failures, transforming a diff to an updated basket. Clients come back, says, oh, you know, when we scan those like nice loyalty cards, we'd like to apply the discount to the basket. But the thing is, our API doesn't handle that. So you scan the barcode, it will return an updated, just the ID of the customer. You need to do a second API call to do that. OK, so second API call, composition, I add one line, flat map, adding a customer. Same old, I implement my function, and in here I say, if I require add a customer, I return add customer. Add custom here, as you see the type, it's an observable of a diff. It's actually a new task, just like the one we're implementing at the moment. And just by returning it here, it will execute in sequence before returning the value. So if I do my API call, and I need to add a customer, I will add a customer, do another API call, and then I will return to the UI. The UI still doesn't have to care about that. The UI doesn't know that I need to do 2 API calls. It will be a bit longer, but in the end, my UI doesn't have anything to care about it. It just says, I want to add this to my basket. Doesn't matter if it's a product that I add or if I'm applying a discount. So all that works seamlessly. Oh, yeah, I think in most countries we're not supposed to sell alcohol to minors, so we should probably take care of that. So we have an API, and it will treat that as an error. So if I'm trying to sell alcohol, it will say, oh, sorry, I can't do that. You should actually add me more details. So I need to send you the birthday of the customer. Wait a minute. I need data from the user here. I actually need to fit this somewhere in the middle of my network flow. So I need to do a call, realize that I need more data, display this to the user, receive the birthday, and then do another API call to set that remotely. That's quite ugly. How do we do that? So we use the last element that we've seen on error resume next. In here, I will start to get a bit more complex. As you can see, I'm using a function that takes a function. So I'm using check for error that takes a continuation. How does that work? So on error resume next will allow me to customize my failure or execute something else afterwards. And I will define my function, nice indentation, like this. So if my error is an error that needs more data, I can specify here a new type of exception that takes my continuation function here. So I will basically create a new exception and add some data to it before passing it through to my UI. And that continuation is actually just how do you do the next API call. The next API call is adding to the basket with the custom data. So in here, I'm adding barcode and data. And the data is provided in the call of the function. So we do need to change a bit the UI, but not that much. What I'm going to do here, I'm going to display a dialog for my error, and then flat map with my continuation. Wait a minute, flat map? I'm talking about dialogues here. So this is where I'm actually going to say Rxify everything. Displaying a dialog here returns an observable of data. I'm actually wrapping my dialog saying that actually displaying a UI is just saying I have a potential value in the end. Same as an API. I don't know when the user is going to click on the button, but at one point he will. And at that point, I'll have a date of birth. Or I'll have an exception. I don't know, he canceled. But it's a potential value. So I'm changing display dialog for to observable of data. And I'm just implementing with continuation that is saying, well, at the end, when I have my data, I can retrieve the value from my exception. And I can apply it with the data that I have now. So at that point is when the dialog is finished, and I want to know what to execute. And I will retrieve it, not hard-coded in the UI. I will retrieve it from the error that was sent from the data layer. That actually works for any type of failures, any type of data that I need. The UI doesn't care. It just says, you told me I needed to get some more data. When I have that data, just resume whatever you were doing. So this is how you could actually do that on Android. So I call that a reactive dialog. You extend a dialog fragment, and instead of showing normally, you wrap the show call here in an observable. And you basically just save the subscriber and just this will like return automatically, and as soon as you subscribe something to it, will display the dialog, and whenever you click on the functions, you will return the value in the observable. So this is quite crazy, right? We now have reactive dialogues. What we have now is like going from, I want to add something to my basket, going to the network, back to the UI, back to the network, back to updating my UI, and the UI in itself didn't really have to care about it. It just said, execute this, and at the end it gets the result. It did have like a small back and forth, but all of it is handled by the data layer. And this is kind of a bit of a recap of what's happening, but what's happening is we add to basket. So I want to add something to my basket. I actually check if my API call was a success or not, and I can define a custom failure. I will add a customer if it's needed, do another API call. I will transform it from a diff to a proper basket. And if there is an error, I will check for that error, display whatever is needed, and do whatever API call I need to continue. All of that crazy behavior that we had to implement is expressed in those lines. This is incredible. This means someone coming to the project reads that and know what the API call is doing. There's no need to click through like an async task to see what is happening on post-execute, seeing if it's calling something else, whatever is happening. All the flow is defined here. And all those functions that we've seen, check API success, add customer if needed, apply diff to, they can be static functions. They can be small things in a module we can completely, fully unit test. All of that can be tested, and all the flow is defined here. This is quite crazy. You can even go one step further and say, at the end, I just changed a tiny bit my continuation. I added data. And by doing this, I can actually use recursion to just say, I can stack multiple failures in a row, saying if my API fails several times in a row, I can keep adding data to it, and I will grow my error handling. And I don't have to store anything in a static member or whatever. It will all go away as soon as the API is finished. So it's really one flow from the point where I say I want to add something to my basket to the point where I get the basket in the end. All of it is handled here. And this is really, really interesting. So all is good. We're quite happy. Maybe a bit mentally tired because it is a big shift in thinking. We really have to think differently about problems when we start using RxJava. Like a bit of functional aspect, composing, really thinking about a pipeline. But it's really, really handy. So on Android, we have actually a set of tools that can help us, including RxAndroid. We are actually at Novoda, we worked in parallel to the guys from Rx, and we have issued a pull request recently. We'll try and get something merged in. That includes the reactive dialogues that I showed. So I have like a couple of generic classes that can help you out on Android. So that's really, really a good resource to go and see. And if you ever want to start just playing around with Rx without doing a proper Android project, just try to grasp the concept a bit more. There's a workshop that I created that is available here. It's on the Novoda repo. And you can just clone it, play around a bit. There's like few level of exercises going from playing with chaining events, transforming, composition, and then playing with asynchronicity and all that stuff. So it's a really easy way to get started with it. So yeah, if you liked what I've said, I guess that's kind of the generic thing that everybody says here, but we are hiring. We do awesome Android work, and not only crazy stuff like that, but really everything on Android. So just drop us an email, just come talk to me, It's a really good company to work at, so feel free to come. I don't know if you have any questions. I went a bit fast, so you're probably going to have some questions. So yeah.
Hi. Just a simple question, but is it possible that external part of your app push observable, or is it only linear? Not sure if I'm clear.
Can you rephrase it?
En français?
Oui, en français.
Ouais, voilà, ce sera plus simple. Non, mais est-ce que voilà, ce qui est prédécrit, c'est très linéaire, on demande quelque chose, on a un résultat, mais est-ce qu'il est possible que ce soit d'autres parties de l'application qui envoient des résultats, même si on n'a pas vraiment demandé ou si on n'est pas dans cette ligne d'action?
So the question is it possible to push data without requesting it, more or less? So no, the concept of reactive programming is different from bus posting, in a sense. But you can actually use it in a way that is really reactive when you just get data all the time. And we've done it on a few projects saying your activity, as soon as it starts, just subscribes to an observable of a certain type. And then that data layer can implement the observable any way you want. It might not send data straight away. It might just be, I will subscribe to updates on location. So my activity implements an observer of GPS coordinates, and then that observable will push through regularly GPS coordinates. So that is like a really push-based scenario. And most of the time, that's what you're going to do. In here, I showed a more like linear approach because it was easier to showcase how we can map and transform stuff. But in any case, the idea is really to consider your UI as dumb as possible. Like the UI should be as stupid as possible. Just says, I need that data of a certain type. I know how to display that, and that's it. And then it's whatever data layer implements it that decide how you push the data or how you fetch it.
Okay, thank you.
Merci pour la présentation. Juste une question au niveau justement de ce flow qui est les observables. Est-ce qu'ils peuvent être arrêtés justement par lui? Je pense notamment à cause du cycle de vie d'Android ou à stopper, poser, ce genre d'opération. Est-ce possible?
So the question is it possible to stop the receiving of events, especially to deal with Android lifecycle and all that? So when we subscribe to an observable, we get a subscription object back, and on that object we can just call unsubscribe, and that's it. So on Android we would store that subscription, call unsubscribe on pause, for example, and that would make sure that we don't leak anything.
Thanks for your presentation. I actually have two questions. The first one is, did you try some backports of Java 8 Lambda, and do you have some feedback on it? Because it's much easier with it. And the second one is it a total replacement for an event bus, or can it coexist with RxJava?
So on the Java 8 bit, I haven't tried. There's also Retro Lambda as a library that I know some people have used it. It's definitely an improvement if you use it because it gets rid of all the boilerplate Func1 at the top and all that really ugly stuff. So I guess it should be working together. I haven't really used it just because not everybody at the company also was comfortable with like all the Lambda annotations. But I think it's definitely something to look into. As for working with Event Bus, I don't see why not, but I think it would become a bit messy. To be fair, we used Event Bus before, like Otto from Square and other types, but I find the RxJava approach, like the reactive approach, nicer because you explicitly subscribe to data. And that actually gives a bit more coherence in the data flow, as in you can actually click through and know where that is going, compared to an event bus where you have that kind of magic happening of just having that type appearing here. That's just a preference, I guess.
Bonjour, du coup super presse. Moi j'avais une question, c'était sur le flat map, notamment la possibilité de paralléliser par exemple les différents appels réseau qu'il y avait. Vous avez dit que vous pouviez en fait, je sais pas, par exemple si on fait un appel pour avoir une basket, puis après on a une réduction qui arrive, donc du coup faire un second appel, qu'on ait ça de manière incrémentale. La question c'est est-ce qu'on peut justement appeler à la fois pour la basket son contenu et son tarif et après merger et le faire de manière parallélisée.
So the question is about when we do composition with FlatMap, can we deal with splitting like multiple tasks at the same time and then merging them back? So there is loads of elements to do that. There's like I think a parallel map, and I haven't looked into all of them. It's definitely possible. There's a lot of control over asynchronicity, so that might get like just a tiny bit more complex there because you can probably specify at that time, do you want that to execute that on a new scheduler, for example? So if you want to like split again in new threads or new things, but it's definitely feasible, yeah.
Hi, thanks for the talk. I've seen the Netflix presentation at Devox, and some of the users, it was quite challenging, and some of the users were having the feedback about having trouble debugging RxJava. So is this something you hit when doing your project, or because when you compose a lot of actions, sometimes you don't know what's going wrong at what point exactly. So is this something that came up in your project, for instance?
So there's a bit of difficulty to debug, as for any concurrency project, because when we add concurrency, then there are actions happening at the same time, and it might get a bit confusing. I don't think I had that many issues. The main change I had to do in the way I debug as well is when I use debugger, you can't really use step through. So it's more about reading that one line when you have like all the different actions mapped together, and just adding a breakpoint in each one of them, and then going forward in execution. And that way you just jump all the boilerplate code. So you go from that action to that action to that action in like a straight line. But yeah, it gets a bit confusing if you have like multiple values pushing at the same time. I don't have a definitive answer on that. I think it's probably the biggest issue we have with concurrency is how do we log properly events or debug properly events, and I don't know.
Hi, thank you for your talk. There is a lot of hype around RxJava right now, and a lot of talks, a lot of blog posts. You said your company switched to RxJava for at least some projects. Are there any downsides or pitfalls that we should be aware of? Or is it just great and awesome, and should we switch every project to it?
I would say it's great and awesome. No, seriously, there's obviously some pitfalls. The first one on Android is lifecycle management. I think you have to understand the fact, like where are the references, especially when you create observers, they have a reference to whatever environment they were in, if they're anonymous classes. So you have to be sure of unsubscribing properly on rotation, or use some other means of dealing with it. So we implemented some sort of caching mechanism that would reattach them on rotation. Some other people are using retained fragments to just basically that way we don't leak the reference. There's different ways of dealing with that. I think the biggest slowdown is just the learning curve. It is quite tough to approach at first. It takes a bit of time for people in the project to get used to it. I think it's worth it in the end because compared to other way big project grows, I think once someone understands RxJava, if it comes to a big project with RxJava, it's easy to understand the code base. But for someone that doesn't know the technology, it is like a bit of a block at the entrance. So what we did is that's why I created the workshop. I animated workshops at my company to get people used to it. So I think that's the biggest blocking, is getting people to understand the technology and getting confident with it.
Okay, thank you.
Sorry, a third question. I think there's a version adapted from RxJava that is called RxAndroid, made by Foursquare, if I remember, that handles threading strategies automatically. Are you using RxAndroid or RxJava?
So RxAndroid is actually just a module that you can add to RxJava to add some helper methods. So including schedulers, it has a scheduler for main thread. It has some wrappers to create observable that will unattach automatically on rotation if they're referenced to an activity. So a couple of helpers around it, but you have to use RxJava and then add that to it.
Yeah, okay. And are you using it?
Yeah, so we actually implemented stuff that we will push back to the community on RxAndroid.
Okay.
Thank you.